Hey champs of ExamsNet, welcome to the question series of ExamsNet. Students, you must have explored our website www.examsnet.com. Examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find so many entrance exam question papers along with their detailed PDF solutions, and you must download our app. The link is available in the description box for the better preparation of your exam. So today, students, we will be solving TSMSET, means Telangana State Engineering, Agriculture and Medical Combined Entrance Test of 14th May 2023 shifted to question paper. Okay, so in this particular video, I'll be solving the physics part of the paper. Okay, so starting from the very first question of the physics series of this question paper, that is question number 81. The question is saying that to match the following means forces with their given relative strength. Okay, so first of all, this question is from the chapter of physical world. Okay, so here we are given with four fundamental forces, that are strong force, electromagnetic force, weak nuclear force, and gravitational force. So the first one is strong nuclear force. So the strong nuclear forces are those forces which acts between inside of the nucleus of an atom, means between, let us say this is a nucleus, and the electrons are revolving around the nucleus, and inside the nucleus there are neutrons and protons. So the strong nuclear force acts between proton-proton pair, or neutron-proton or neutron-neutron pair. So it is the strongest fundamental force in nature, and we have taken its strength as 1 according to question. So for the A, we match A with F. Okay, A with F. Now B is weak nuclear force. The weak nuclear forces are those forces which comes in play in conversion of neutron to proton or vice versa. Let us say the weak nuclear force acts for the radioactive decay. Okay, for example, beta decay means let us say a neutron is converting into a proton plus 1 electron plus anti-neutrino. Okay, for such type of reactions, means for such type of decay, beta decay, there acts weak nuclear forces. For these weak nuclear forces, the power strength is 1 over 10 to the power 13, means 10 to the power minus 13. Okay, so for B, we match it with H. So for A, it is F. For B, it is H. Okay, and third one is electromagnetic force. The electromagnetic force acts between the charged particle. Okay, so and its strength with strong nuclear forces 1 over 100 times of. Okay, so this C matches with E. C matches with E, that is 1 over 10 to the power minus 2 times. Okay, and gravitational force, the gravitational forces acts between bodies with masses, for example between planets, sun and planets. Okay, so its relative strength to strong nuclear forces 10 to the power minus of 39. So it matches with I. So D matches with I. So among these four options, the option, let us say A matches with F, A matches with F, B with H, C with E, and D with I. So option C is the correct answer. Okay. Now next question 82. A physical quantity x is given by x equals to 2k cube L square over m root n. The percentage errors in measurements of k, L, m, and n are 1, 2, 3, 4% respectively. We have to find the value of x. Okay, so this question is from the chapter of units and measurements. Okay, so we are given with capital X is equals to 2k cube L square over m root n. Okay, so and percentage error in k is 1%, in L it is 2%, in m it is 3%, and in n it is 4%. Okay. So total percentage error in X will be total percentage error of X. It will be del X over X into 100 since it is percentage error. Na? So it will be equals to K cube means 3 delta K over K into 100 plus L square means 2 into delta L over L into 100 plus delta M over M into 100 and plus root n means n to the power 1 by 2. So it will be 1 by 2 into delta n over n into 100. Okay. So just put the values given in the questions. So it will be what? It will be equals to this 3 into 1% plus 2 into 2% plus 3 3% plus this 1 by 2 into 4%. Okay, into 4%. So it will be 3 plus 4 plus 3, 2 to the 4 plus 2. So it will be 4, 3, 7, 8, 9, 10, 11, 12, 12%. Okay, so the percentage error in X will be 12%. So our correct answer is option C. Now next question 83. The displacement time graphs of two moving particles make angles of 30° and 45° with the time axis. The ratio of their velocities is okay. So this question is from the chapter of motion in a straight line. Motion in a straight line. Okay. So we are given a displacement time graph of two particles. Let us say this is particle A, this is particle B, having angle 30° and 45°. Okay, so we have to find the ratio of these velocities. Okay, so tan theta in this question, tan theta is the velocity, and velocity is what? Displacement over time. Displacement over time. So for the first particle, let us say for first particle, so V1, it will be tan theta 1. V1 means velocity of one particle. Okay, velocity of first particle, it will be equals to tan theta 1. And for second particle, also the velocity means V2. Velocity means V2 will be tan theta 2. Tan theta 2. Let us say 30° will be A and 45° will be B. Okay. So this V1 over V2 will be equals to what? Tan theta 1 over tan theta 2. So it will be equals to tan 30 over tan 45°. So since theta 1 is means A particle having angle 30° and theta 2 means B particle is having 45°. So V1 over V2 tan 30 over tan 45 means 1 over root 3 means it will be 1 ratio root 3. So the correct answer is option D. Okay. Now next question 84. A projectile is given an initial velocity of I plus 2j meter per second. The Cartesian equation of its path is okay. So we are given this question from the chapter of motion in a plane. Okay, motion in a plane. See, we are given the with the initial velocity. Okay, so initial velocity is given as initial means we are given u. Okay, so initial velocity u is ith cap plus 2 j cap meter per second. So we have to find the Cartesian equation for this. For first of all, the acceleration due to gravity in this question will be acceleration due to gravity will be equals to g. Okay. Now let us draw it as, let us say this is the first particle, let us say this is the second one, and this is their initial velocity. Okay, this is a projectile motion, let us say mark it as 1 is 2 and this is angle theta. So if we resolve this angle theta into two components, so axis will be of u cos theta and y axis will be of u sin theta. Okay. So from this, the tan theta will be equals to what? Tan theta is perpendicular over base. So it will be this 2 over 1. 2 over 1. So the using the formula for the path equation, y is equals to x tan theta. Since tan theta, this perpendicular over base na, means this y over x na. So y over x. So from here y will be x tan theta na. So it will be equals to x tan theta minus gx square over 2 u square cos square theta. This is the path equation for any projectile motion. Okay. Now u will be equals to under root of 1 square plus 2 square. So means under root of u square cos square theta plus u square sin square theta. Okay. So for this we get u as this 1 square plus 2 to 4 square 2 to 4. So it will be under root of 5. So this y will be equals to x tan theta. Let us say x into 2. Tan theta is y over x means 2 over 1. Na? So it will be equals to 2 and minus g, gravity is 10, x square over 2u square means 2 into 5 into 1 over 5 cos square theta. So it will be 2x minus 5x square. This is our final answer. Since the y-axis is given as 2 and x-axis is given as 1, therefore we have written here 2 over 1. Okay. So the correct answer is option B, that is y equals to 2x minus 5x square. Now next question 85. If the radii of circular path of two projectiles of same mass are in the ratio of 1:2, then to have a constant centripetal force, the ratio of their speeds should be. Okay. So this question is from the chapter of laws of motion. Laws of motion. So in this question, we are given with the ratio of the radius of two circular paths, and the ratio is R1 over R2 is given as 1:2. Okay. And ratio of their masses is given as 1:1 since these are of same masses. Na? So for this, since the masses are same, so their centripetal force will be constant. Okay. And in question also it is given that the centripetal force is constant. Centripetal force is given as constant 1. Okay. So we know that centripetal force is given as centripetal force. It is equals to F C. It is equals to mv square over r. Okay. So let us say for the first particle. For first particle, the centripetal force can be written as Fc1. It is equals to m1 v1 square over r1. Okay. And for second part, let us say this is equation 1. For second particle, the centripetal force is written as Fc2. It is equals to m2 v2 square over r2. So since the centripetal force is constant, so thus this Fc1 must be equals to Fc2 as given in the question. Okay. So equating these, so m1 v1 square over r1 will be equals to m2 v2 square over r2. Since the masses are same, so m1 m2 cancels. So v1 square over v2 square will be equals to r1 over r2. And r1 over r2 is what? 1/2. So it will be 1/2. So v1 over v2 will be equals to 1/√2. So the ratio of the speeds is 1 over root 2, means option B is the correct answer. Okay. So the next question is 86. The angle between force F equals to 3 iota cap plus 4 j cap minus 5 k cap and displacement D equals to 5 iota cap plus 4 j cap plus 3 k cap is. Okay. So this question is again from the chapter of laws of motion. Laws of motions. Okay. We are given with the force F is equals to 3 iota cap plus 4 j cap minus 5 k cap and displacement D is equals to 5 iota cap plus 4 j cap plus 3 k cap. So we have to find the angle between them. We know that F dot D is equals to, since it is a dot product, so we write FD cos theta. Okay, so cos theta will be equals to F dot D over FD. Okay, so it will be equals to F dot D means 3 iota cap plus 4 j cap minus 5 k cap and dot 5 iota cap plus 4 j cap plus 3 k cap over F cross D. So F cross D will be it will be 3 iota cap plus 4 j cap minus 5 k cap cross 5 iota cap plus 4 j cap plus 3 k cap. Okay, so it cos theta will be equals to 3 5 15 plus 4 4 16 5 3 15. Okay, and since it is a cross product, for cross product I cross j equals to k, j cross k equals to I, and k cross I equals to j, and I cross I is 0, j cross j is 0, and k cross k is 0. So solving it, we get denominator is 50. So we get 15, 15, 60 over 50. So it will be 0.3. Okay. So 32. So cos theta is equals to 0.32, means theta is equals to cos inverse 0.32. So the correct answer is cos inverse 0.32. That is option B is the correct answer. Okay. Now next question 87. A bomb of mass 16 kg explodes into two pieces of masses 4 kg and 12 kg. The velocity of the 12 kg mass is 4 meter per second. The kinetic energy of the second piece is. Okay. So this question is from the chapter of work, energy and power. Work, energy and power. Okay, in this question we have to find the kinetic energy of the second piece. Okay, so initial mass m is given as 16 kg. Okay, mass of first piece, is given as 4 kg, and mass of second piece is given as 12 kg. Okay, and velocity of first particle v1 is given as velocity of 4 meter per second. Okay, no, sorry, V2 is given as of 12 kg, na? So V2 is given as 4 meter per second, and we have to find the kinetic energy of the second piece. Okay, so here we will use the law of conservation of momentum. Law of conservation of momentum. So what is the law of conservation of momentum? That is initial momentum is equals to final momentum. Okay. So initial momentum means this bomb is exploding into two pieces. Na? One bomb is exploding into two pieces. And here we are given of 4 kg. This is of 12 kg and its velocity is given as 4 meter per second and its mass is 16. So MV means initially the momentum should be equals to final. So M into V will be equals to this M1 V1. Let us say this is 1 and this is 2 plus M2 V2. Okay. And initially the particle it at rest, so this V will be equals to 0. So this M1 V1 will be equals to minus of M2 V2. Okay. So M1 4 into V1 is equals to minus of M2 12 into V2 4. So V1 is equals to minus of 12 meter per second. Let us say this is equation number 1. And in this question, we are asked to find the kinetic energy. So kinetic energy is what? Half mv square. Kinetic energy of second piece means half m2 into v2 square. So it will be equals to half m2 is what? 12 into v2 square. v2 is 4. V2 is 4 na? Okay. Yeah, V2 is 4 meter per second. So 12 into 4 is square. So it will be equals to 2, 6 are 12. So 6 into 4, 4 is 16. 16, 6 are 96. Okay. So the kinetic energy of the second particle is 96, means option C is the correct answer. Okay. Now next question 88. A constant torque acting on a uniform circular wheel changes its angular momentum from A0 to 4A0 in 4 seconds. And the magnitude of the torque is, okay. So this question is from the chapter of a system of particles and rotation motion. System of particles and rotational motion. Rotational motion, okay. In this question, we are given a constant torque which is acting on a uniform circular wheel, and its angular momentum changes from A0 to 4A0. Okay, let us say initially the angular momentum Li is equals to A0, and final momentum is what? Lf is given as 4A0. Okay, and time taken is 4 seconds. Time is 4 seconds. So change in angular momentum delta L will be equals to final momentum minus initial momentum, means 4A0 minus A0. So it will be equals to 3A0. So magnitude of the torque tau is what? Change in angular momentum over change in time. So change in angular momentum is 3A0 over time is 4. So 3 by 4 A0 is the correct answer, means option A is the correct option. Okay. Now 89th question. A particle performs uniform circular motion with an angular momentum L. If the frequency of the particle's motion is doubled and the kinetic energy is halved, then the angular momentum will become. Okay, so this question is from the chapter of motion in a plane. So according to question, here the particle is performing uniform circular motion and angular momentum is L. Okay, so initial angular momentum is given as L. So initial angular frequency will be omega, let us say. Okay, initial angular frequency will be omega. So initial kinetic energy will be initial kinetic energy, let us say it is Ke. Okay, and final angular momentum will be final angular frequency, sorry, final angular frequency will be since the frequency of the particle is double, so let us say the final angular frequency is 2 omega and final kinetic energy gets halved, so it will be Ke by 2. So for this the rotational kinetic energy will become half I omega square, where I is the moment of inertia. Okay, so for this the angular momentum will be equals to L is equals to what? I into omega. So L is equals to, from here we can write I is as 2 into kinetic energy over omega square from here. So just put the value of I here. So 2 kinetic energy over omega square into omega. This omega 1 power cancels. So we get angular momentum as 2 Ke over omega. Okay. So the new kinetic energy will be, according to question, the new kinetic energy will become 2 into kinetic energy and omega will be 2 omega. So new angular momentum will be equal Ln. Let us say it is new angular momentum Ln. It is new kinetic energy, let us say N, and new angular frequency, let us say omega N. So new angular momentum Ln will be equals to this 2 Ken over omega N. So it will be equals to, according to question, The new kinetic energy is the half of the previous one, na? New kinetic energy is half of the previous one, not doubled. Half of the previous one. So 2 into kinetic energy over 2 over omega n, twice of frequency. So solving it, we get L2 cancel. We get Ke over 2 omega, na? Ke over 2 omega means L is 2e by omega and mu ln is Ke over 2 omega means in place of Ke by omega, here we can write L by 2. From this we can write Ke by omega equals to L by 2. So ln will be equals to L by 4 means previous angular momentum divided by 4. So the new angular momentum will be L by 4. That is option D is the correct answer. Okay. Now next question 90. The displacement of a particle is given by the relation x equals to this 4 cos pi t plus sin pi t. We have to find the amplitude of the particle. Again, this question is from the chapter of motion in a plane. So we are given x is equals to 4 cos pi t plus sin pi t. Okay. Now comparing it with the standard equation. The standard equation is what? A sin omega t plus phi for the displacement of any particle. So comparing it, we get equation. Let us say this is equation 1, this is equation 2. So we have to correct the equation 1 in the format of equation 2 to compare the amplitude. So we can write x as 4 cos pi t plus sin pi t. Let us say multiply this equation by root 2 and numerator and denominator by root 2 so that we can compare it with the standard equation. Okay. So root 2 over root 2. So we will get x is equals to 4 root 2 over 1 by root 2 cos pi t plus 1 by root 2 sin pi t. Okay. Sin pi t. Now it will become x is equals to 4 root 2 cos pi t and 1 by root 2 is what? Sin pi by 4. Okay. And here also 1 by root 2 we can write it as cos pi by 4 into sin pi t. Okay. Now, so it will become x is equals to 4 root 2. We can write cos A sin B plus sin A cos B. So we can write it as 4 root 2 sin A minus B. Okay, just use the formula cos A sin B plus sin A cos B. So sin A minus B. Okay, so now compare this. Let us say this is equation number 3. Now compare this equation 2 with equation 3. So we get amplitude A as 4 root 2. So the correct answer is option C, that is 4 root 2. Now next question 91. A body of mass m is at height r from the surface of the earth where r is the radius of the earth. If the body is taken from here to a height of 3r from the surface of the earth, the increase in the gravitational potential energy of the body is, okay. So this question is from the chapter of gravitation. Okay. Now according to question, let us say this is the earth and its radius is r. Okay. A body of mass m is height r from the surface of the earth. Let us say this is from height from the surface of the earth. Okay. If the body is taken from here to a height of 3r from the surface of the earth, let us say the body is taken at the height of, let us say this is 3r from the surface of the earth, we have to find the increase in the gravitational potential energy of the body. Okay. So given the mass of the body is m and radius is given as r. Okay. Radius is given as r. From the radius is r. Let us say the initial height is r from the surface of the earth. Initial height. Initial height is given as r from the surface of the earth, and final height is 3r from the surface of the earth as given in the question. Okay, so for this, the gravitational potential energy at height h, let us say for h, the gravitational potential energy is given as mgh over 1 plus h over r from the surface of the earth. Na? So now we will use the conditions that are given in the questions. Okay, for h equals to r, when the initial height is r from the surface of the earth, at that time the gravitational potential energy will become mg r over 1 plus r over r. Okay, so it will be equals to what? mg r over 1, r plus r over r. So this r cancels. So u1 will be equals to, this is 2r, so 2r will also get cancelled. So we get mg r by 2. Okay, mg r by 2. And for when height is 3r, we get u2 is equals to mg 3r over 1 plus 3r over r. So it will be equals to mg 3r over this r plus 3r over r. So it will be equals to mg 3r over 4r over r. So it will be equals to 3 by 4 mg r. Let us say this is equation 1, this is equation 2. Okay, so according to question, we have to find the increase in the gravitational potential energy. So increase in gravitational potential energy will be equals to this equation 2 minus equation 1. That is u2 minus u1. u2 is what? 3 by 4 mgr, and u2 is 1 by 2 mgr. So subtracting it, we get mgr by 4. Okay, so correct option is option D. Now next question 92. The ratio of the areas of cross sections of 3 wires, 1:2:3, and ratio of the Young's moduli of their material is 3:1. If the 3 wires are of same length and same stretching force is applied to the 3 wires, we have to find the ratio in the elongations of the 3 wires. Okay, so this question is from the chapter of mechanical properties of solid. Okay, mechanical properties of solids. Now, according to question, we are given the ratio of the cross sections, means A1 ratio equal A1, A2, A3. These are in ratio of 1:2:3, and Young moduli Y1 ratio, Y2 ratio, Y3 is equals to 3:2:1. Okay. Okay, these are having same length L and stretching force F is same. Okay, so we know that the Young's modulus F is given by stress over strain. It is equals to force over area into original length into elongation in length. Okay, so Y1 will be equals to F1 over A1 into L1 over delta L1. So it will be equal, so from here delta L1 will be equals to F1 L1 over A1 into Y1. Okay, similarly Y2 will be, for Y2 delta L2 will be equals to F2 L2 A2 into Y2, and L3 will be equals to F3 L3 A3 into Y3. Okay, so as given in the question, F is same, means F1 equals to F2 equals to F3, and lengths are same, means L1 equals to L2 equals to L3. So we have to find the ratio of delta L1, delta L2, delta L3. So delta L1 ratio delta L2 ratio delta L3 will be equals to area ratios are 1:3 and Young's modulus 3:1, means this will be equals to delta L1 will be equals to these are fixed na, so let us say this is constant K, and A1 is what? 1:2:3, 3:1 means. Acha, okay. So assuming these constant K, so L1 ratio, L2 ratio, L3, this will be equals to 1/3 ratio 1/4 ratio 1/3. Okay. Since A1 dot Y1 means 1.3, 1.3, this will become K over 2.2, 2.2. This will become K over A3 dot Y3 means 3.1, 3.1. So from here we can write delta L1 over delta LU. It will be equals to um this K over 3 over K over 4 and over delta L3 means over K over 3. So in terms of ratio, we can write them as 1/3 ratio 1/4 ratio 1/3. So from this, we can write ratio of the elongations as delta L1 ratio delta L2 ratio delta L3 as 4:3:4. Okay, means the correct option is option A, that is 4:3:4. Okay. Now next question. When a large bubble rises from the bottom of a lake to the surface, the volume of the bubble becomes 5 times its volume at the bottom of the lake. If H is the atmospheric pressure expressed in terms of water column height, then the depth of the lake is. Okay. So this question is from the chapter of mechanical properties of fluids. Mechanical properties of fluids. Okay. Now, okay, in this question, we are given a large bubble that rises from the bottom of a lake to surface. Let us say this is a lake and this is the surface of the lake. Okay, so a bubble rises from the bottom to the surface of the lake, and this volume of the bubble becomes 5 times its volume at the bottom of the lake. Okay, and H is the atmospheric pressure in terms of water column height. We have to find the depth. Okay, so atmospheric pressure height, let us say H is the atmospheric pressure height. Okay, atmospheric pressure height. So atmospheric pressure is given as P naught will be equals to rho GH. Okay, where rho is the density of the water. Okay, let the depth of the water, let us say this depth be L. Okay, so pressure at depth L will be pressure at depth L. It will be equals to this pressure P naught, which is atmospheric pressure, plus rho G L. Okay. So it will be equals to P naught is what? Rho G L. Rho G H, sorry. P naught is what? Rho G H na. So it will be rho G H plus rho GL, and we have used the atmospheric pressure height as capital H as given in the question. So in terms of this small h, write capital H. In terms of small h, write capital H. Okay. So this pressure at depth L will be equals to taking rho G common. It will be H plus L. Okay. Let us say this is equation number 1. Okay. Now the surrounding temperature is constant. According to the question, the surrounding temperature is constant. So the process will be isothermal. So for isothermal process, we will use the Boyle's law. Using Boyle's law, that is P1 V1 is equals to P2 V2. Okay. Since P1 is what? This rho G H plus L. So P2 will be equals to rho G H. Okay. And V2 is 5V1 as given in the question. So put the values in the Boyle's law. So putting these 3 values in the Boyle's law, we get rho G H plus L into V1. Rho G H plus L into V1 equals to P2 rho G H into V2, that is 5V1. Okay. So solving it, we get L is equals to 4H. So the depth of the water is 4H. Okay. The correct option is B. Now next question 94. A water drop breaks into 64 identical droplets of each surface area 10 to the power minus 7 meter square. If the surface tension of water is 0.07 Newton per meter, the increase in the surface energy in the process is. Okay. Again, this question is from the chapter of mechanical properties of fluids. Mechanical properties of fluids. Okay. We have to find the increase in the surface energy. Okay. So given in this question, the surface area of each droplet as 10 to the power minus 7 meter square. This is the surface area as given in the question. And surface tension is what? 0.07 Newton per meter. Okay. Now the number of droplets given as 64. N is given as 64. So the surface energy change will be equals to, let us say, delta SE. It will be equals to T into delta A, where delta A is what? Change in the area, okay? And T is what? Surface tension. So let us say A initial means initial area is what? 4 pi r square, and there are number of droplets 64. So it will be equals to 4 pi r square into 64. Let us say initial radius is r1. Huh? Okay. So since the volume will always remains constant, volume will be constant. So V initial must be equals to V final. Okay. Acha, wait a minute. If water drop is breaking into 64, na, so this 64 one will be a final one. A final. Area initially will be 4 pi r square only. Okay. This is initial area and this is final area when the water droplet is is breaking into 64 further droplets. Okay. So volume initial will be equals to volume final. So initial volume will be 4 by 3 pi r cube and final will be 4 by 3 pi new radius r1 cube into 64. So from here, 4 by 3 pi cancels. So r cube will be equals to r1 cube into 64. So this r1 cube will be equals to r cube over 64. So it will be r will be equals to r over 4. Okay. Let us say this is equation number 1. That is r1 will be equals to r by 4. So delta A final, from here we can write delta A final as 10 to the power minus 7 as given in the question. Area is 10 to the power minus 7 into 64. So it will be equals to 64 into 10 to the power minus 7 meter square. So delta A initial will become delta A final only, because final is 4 pi r1 square into 4 pi na. So it will be equals, so delta A, basically delta A will be equals to delta A final minus delta A initial minus delta A initial. So it will be equals to final is what? 64 into 10 to the power minus 7 into initial is 16 into 10 to the power 7. Okay, so surface energy change will be tension into this delta A. So it will be equals to tension is what? 0.07 into this 64 into 10 to the power minus 7 minus 16 into 10 to the power. This is minus 7. Okay. So delta SE will be equals to 336 into 10 to the power minus 9 joule. This is our final answer. Okay. So from you students might be thinking from where delta A initial value came na. So delta A initial will be what? At first we have written the delta initial is 4 pi r square na, and from here this small r is equals to 4 r1. So just put the value of small r here. 4 pi r square is what? 4 pi 4 r1 square na, whole square. So it will be 4 pi into 4 16 r1 square. So this will be equals to 16 into 4 pi r1 square, which is basically the area. And according to question, the area is what? 10 to the power minus 7. So we can write here 16 into 10 to the power minus 7. Thus, we have written in place of delta A initial, we have written 16 into 10 to the power minus 7. That's why we have solved this like this. Okay, so our correct answer is 336 into 10 to the power minus 9 joule. Now next question 95. Steam at 100 degrees Celsius is added to 150 gram water to increase its temperature from 20 degrees Celsius to 40 degrees Celsius. Okay, the total mass of water is 40 degrees Celsius. Is we have to find the total mass of the water. So this question is from the chapter of thermal properties of matter. Now, according to question, the steam temperature is what? Steam temperature is 100 degrees Celsius. Okay. And initial water mass is given as 150 gram. Okay. And initial temperature is 20 degree and final is 40 degree. Okay. 20 degree Celsius and 40 degrees Celsius. Okay. And latent heat is given as 540. This is capacity 1 calorie per gram. So now we will use the principle of calorimetry to find the total mass of the water. So calorimetry principle we are using in this case. So according to calorimetry principle, the heat lost by the steam will be equals to heat gained by the water. Okay. Heat lost by steam, it will be equals to heat gained by water. So heat lost by the steam means M into L vaporization plus M into S into delta T, S of water. It will be equals to M mass of water into S of water into delta T. So it will be M into L vaporization means 540 plus M into S water. Specific heat is 1 calorie per gram per Celsius. So into 1 into delta T. Delta T is what? 100 minus 40. It will be equals to mass of water 150 gram into SW1 into delta T means 40 minus 20. So just solve it. We will get the mass of the water. So it will become 540 m plus 60 m. It will be equals to 300. 300 or 3000? 40 minus 20. Acha, 3000. So it will be 600 m will be equals to 3000. So m will be equals to 0, 0, 0, 0 cancel. 6 5s are 30. So mass is 5 gram. So total mass will be initial mass plus final. Initial is 150 plus final 5 grams. So it will be 155 gram. This is our final answer. So the correct option is option. Now, next question is 96. A blacksmith fixes circular iron frame on the wooden wheel of a bullet cart. The diameter of wooden wheel and circular iron frame are 5.012 meter and 5 meter respectively. And temperature is at 27 degrees Celsius. We have to find the temperature to which the iron ring must be heated so as to lift the wooden wheel is. Okay. So this question is from the chapter of thermal properties of matter. Okay. We are given with the diameter of wooden wheel and circular iron frame. So diameter of wooden wheel is wooden wheel. It is given as what, 5.012 meter, and diameter of circular iron frame. Circular iron frame. It is given as 5 meter, okay, and temperature is given as 27 degree Celsius. Now, let us say we will find the increase in the length. Okay, so the length increases thermally. So delta L increase in length will be L1 minus L0, where L1 is the final diameter. Okay, L1 is final diameter and L0 is the initial diameter. Okay, diameter, and there is a relation between this increase in length and temperature, and that relation is delta L is equals to L naught alpha delta T. So delta T is what? Increase in temperature, it is T2 minus T1, and delta L is L1 minus L naught, where T2 is the final temperature and T1 is the initial temperature. So from this we get delta T is equals to delta L over L naught alpha into L naught, where alpha is what? Linear expansion coefficient. Linear expansion coefficient, and from question its value is given as 1.2 into 10 to the power minus 5 per Celsius. Okay, so its value is what given as 1.2 into 10 to the power minus 5 per degree Celsius. Okay, C inverse. So we can write delta T as T2 minus T1. It is equals to L1 minus L0 over alpha L0. Okay, and L1 is given as what? This is L1 5.012 and L0 5 meter. Okay, so put these values in the value of delta T. So T2 minus T1 means T2 minus T1 is 27 degrees Celsius. It is equals to L1 means 5.012 minus L0 5.000 over alpha means 1.2 into 10 to the power minus 5 into L0 means 5. So solving it, we get T2 is equals to 0.012 over this 5 into 1.2 into 10 to the power minus 5 plus this 27. So solving it, we get T2 as 227 degrees Celsius. So our final answer is 227, means option B is the correct answer. Now next question 97. 2 moles of triatomic gas gamma equals to 4 by 3 at temperature 327 degrees Celsius expands adiabatically such that its volume becomes 8 times the initial volume. Later the temperature of the gas is doubled in an isochoric process. We have to find the total work done in the process. Okay. So this question is from the chapter of kinetic theory of gases. Kinetic theory of gases. Okay. So we are given with 2 moles of triatomic gas. 2 moles means here N is equals to 2 and gas is triatomic gas for which gamma is given as 4 by 3. This gamma is called the adiabatic constant. Okay. Or we can also say it adiabatic ratio or adiabatic constant. Okay. And temperature is given as 327 degrees Celsius. Okay. We know that for triatomic gas, the value of CV means specific heat at constant volume. It is equals to 3R. Okay. Let us say initial volume is VI. Initial volume is VI and final volume is VF. Okay. And according to question, the final volume is 8 times the initial volume means 8 of VI. Okay. So we have to find the temperature. Okay. So in any adiabatic process, the work done is given as delta U is equals to NCV delta T. So first of all, we have to find the value of delta T. Since we know the value of N, we know the value of CV. So we have to find this delta T. And we know that for adiabatic constant, TV gamma minus 1 equals to constant for adiabatic process. So we can write T1 V1 gamma minus 1, it is equals to T2 V2 gamma minus 1. So from this we can write T2 over T1, it is equals to V1 gamma minus 1 over V2 gamma minus 1. Or we can write T2 is equals to T1 V1 over V2 gamma minus 1, where V1 is Vi and V2 is Vf. So it will be equals to T1 Vi, and Vf is 8 times of Vi into gamma minus 1. So it will be equals to T1 is what? 327. 327 means plus 273. So it will be converted into Kelvin, means 600 Kelvin. So we can write 600 into Vi. Vi cancels 1 over 8. Gamma. Gamma value is given as 4 by 3 minus 1. So solving it, we get 600 into 1 by 2. 1 by 8, 1 by 3. So it will be 600 into 1 by 2 cube into 1 by 3. See, this 1 by 3 cancels. So we get 600 over 2 means 300. So delta T, T2 will be equals to 300. Okay. So from this we can find delta T is equals to, initially it is what? 600 and final is 300. So 600 minus 300, it will be what? 300 Kelvin delta T. Okay. So the work done will be equals to N CV delta T. So it will, N is 2, CV is 3R and delta T is 300. So it is 1800 R. Okay. So the answer is 1800 R. Okay. Now next question 98. If the temperature of a gas is increased from 27 to 159 degrees Celsius, then the percentage increase in the RMS speed of the gas molecule. Okay. So this question is again from the kinetic theory of gases. We have to find the RMS speed. Okay. Now initial temperature T1 is given as 27 degrees Celsius. Final temperature T2 is given as 159 degrees Celsius. And we know that the RMS value, Vrms is equals to under root 3 kBT by M. Okay. Means this Vrms is directly proportional to under root of T. So for T equals to 27 degrees Celsius means 27 plus 273. We will get 300 Kelvin. Okay. And so Vrms will be directly proportional to this 300 Kelvin. Okay. Means it will be equals to 17.32 meter per second. And for T2, T2 is given as what? T2 is 159, means 159 plus 273. So it will be equals to 932 carry 1, 853 carry 1, 3 or 1, 432. So it will be Vrms will be equals to, this is in terms of Kelvin. So for T2, Vrms is directly proportional to under root of 432, means it will be equals to 20.78 meter per second. So percentage error will be equals to percentage error. It will be equals to delta Vrms over original Vrms into 100. So delta Vrms means 20.78 minus 17.32 over original. Original is what? 17.32 into 100. So solving it, we get percentage error is equals to 20%, means option D is the correct answer. Okay. Now next question 99. A source emitting sound is tied to one end of a string of length 50 centimeter and is rotated with an angular speed of 40 radian per second in the horizontal plane. Okay. The ratio of the maximum and minimum frequencies of the sound heard by an observer standing at a distance of 10 meter from the fixed end of the string is. Okay. So this question is from the chapter of waves. So we have to find what? We have to find the ratio of maximum and the minimum frequencies. So in this question, we are given with the length of the string. Okay. Means we are given with R equals to 50 centimeter, means 0.5 meter. And angular speed. Angular speed is given as 40 radian per second. 40 radian per second. And speed of sound is given as, speed of sound in air is given as 340 meter per second. Okay. So using the formula V equals to R into omega. So R is 0.5 and omega is this 40 radian per second. So we get V is 20 meter per second. Okay. So for maximum frequency, we know the formula. Maximum frequency equals to standard frequency into V over this Vs minus of V. Okay. Where this V is the speed of source sound and this Vs is the speed of the sound. V is the source speed. Source speed. Okay. Source sound speed and Vs is the original speed of the sound. So just put the values here. So we get F maximum. Acha, first we will write F minimum. Okay. F minimum will be equals to same F standard into V over Vs plus V. Okay. The difference between maximum is and minimum is here it is negative sign and here it is positive sign. Okay. So we have to find the ratio of maximum over minimum. Na? So maximum over minimum will be equals to this F standard over F standard into V over Vs minus V into V over Vs plus V. So this cancels. So we get F maximum over F minimum. It will be equals to Vs plus V over Vs minus V. So this will be equals to Vs is what? 340 and V is, we have find the V that is 20 meter per second. So 340 plus 20 over 340 minus of 20. So we get 360 over 320. So it will be equals to 0 cancels 9 over 8. So hence the ratio of F maximum over F minimum is 9:8. This is our final answer. So option D is the correct answer. Okay. Now, next question, 100th one. One end of a string is tied to the ceiling of a lift and a load is attached at the bottom end of the string. Okay. When the lift is moving in the upward with an acceleration of 2.1 meter per second square, the speed of the transverse wave at the lower end of the string is 88 meter per second. Okay. 88 meter per second. If the lift moves downward with an acceleration of 1.9 meter per second square, then speed of the transfer wave at the lower end of the string is okay. So this question is again from the chapter of waves. So first of all, the acceleration due to gravity G is given as 10 meter per second square. Okay. According to question, when the lifts move upward, at this time, the acceleration, let us say A1 is given as 2.1 meter per second square. Okay. And when the lift goes downward, the acceleration is given as 1.9 meter per second square. This is for downward, this is for upward. Okay. And speed of the transverse wave when lift is going upward means V1 is given as 88 meter per second. 88 meter per second. Naha. So using the formula for the velocity, we know that velocity is equals to under root of T over mu, where T is the tension in the string and mu is the mass per length. Mu is, we know that mass per length and T is the tension. Okay. So, and we know that T is what? M into net acceleration. Okay. So, let us take the case 1. Case 1 means when the lift goes in the upward direction. Okay. When the lift goes in the upward direction. So, the net acceleration will be this A1 plus this gravity G. So, it will be equals to A1 is what? 2.1 meter per second square. 2.1 plus gravity is 10. So it will be 12.1 meter per second square. So for this T, tension will be equals to mass into acceleration, M into 12.1. Okay. Let us say this is equation 1. Now consider the case second. For case second means when the lift goes in the downward direction. Okay. So for downward direction, A net will be equals to this G minus A2 because the lift is going in a downward direction. So we will use negative sign. So G is 10 minus A2. A2 is what? 1.9 meter per second square. So 1.9. So it is 8.1 meter per second square. So for this, tension is equals to m into 8.1. Let us say this is equation number second. So now putting these values T1 and T2 in the equation of velocity means V1 is equals to under root of T1 over mu, where mu is mass per length. So from here we get V1 is equals to under root of m into 12.1 over mu. Let us say this is equation 3, and V2 will be under root of T2 over mu. It will be under root of m into 8.1 over mu. Okay, let us say this is equation number 4. Now divide equation 3 by equation 4. So we get V1 over V2 is equals to this mu cancels. So we get under root of T1 over under root of T2. So it will be equals to under root of this m into 12.1 over this m into 8.1. This m cancels. So solving it, we get V2 is equals to V1 into T2 by T1 means under root of 8.1 over 12.1. And since we are given with the velocity as 88 meter per second, so just put the value here. So it will be equals to 88 into under root of 81 over 12.1. So we'll get our answer is 72 meter per second. This is our final answer. So from these 4 options, option D is the correct answer. So next question is 101. The focal lengths of the objective and the eyepiece of a compound microscope are 2 centimeter and 3 centimeter respectively, and the distance between them is 15 centimeter. The final image formed by the eyepiece is at infinity. Okay. The distance of the object and the image produced by the object from the objective lens are respectively. Okay. So this question is from the chapter of ray optics. Okay. We are given with the focal length of the objective as objective focal length as what 2 centimeter. Okay, and focal length of eyepiece focal length as 3 centimeter. Okay, and distance between objective and eyepiece is objective and eyepiece distance is given as 15 centimeter. And according to question, the image is forming at the infinity. Okay, infinity pe final image is forming. So we have to find the distance of the object and the image produced by the object. Okay, so for this, if the image is formed at the infinity, then the object should be kept as the focus, means the object should be kept as 3 centimeter to form the image at infinity. Okay, so the distance of the image from the objective lens will be this 15 minus 3. It will be equals to 12 centimeter. This is the distance of the image formed by the objective lens. Okay, of the objective lens. Now let us say this is equation number 1. Now using lens formula, we can write 1 over f is equals to 1 over v minus 1 over u. So it will be equals to 1 over f. It will be equals to 1 by 2 means objective focal length. Okay, so 1 by 2 will be equals to 1 over v means 12. This minus 1 over u means x. Okay, so from here we get x is equals to minus 2.4 centimeter means the distance of the object and the image produced by the object from the objective lens is this minus 2.4x. So from this option A, that is 2.4 centimeter, and this 12 centimeter is the correct answer. Okay, now next question 102. In a single slit diffraction pattern, the slit is illuminated with light of wavelength 6000 angstrom. Okay. If the slit were illuminated by a light of wavelength lambda, the angular width of the central maximum decreases by 30%. Then we have to find the lambda. Okay. So this question is from the chapter of waves. So in this question, when the wavelength is 6000 angstrom, decrease in angular width is 30%. Okay. So let us say the original angular width be beta. Okay. Let original angular width, it is beta. So new width will be this beta minus 30% of beta. Now, since it is decreasing by 30%, so it will be beta minus 30% of beta. So it will be equals to beta minus 30 over 100 into beta. So it will be 0.7 beta. Okay. So now the fringe width is given as the fringe width. We know that fringe width is given by beta is equals to lambda d over d, where let us say a monochromatic light from a coherent source is coming. This is slit and wavefronts are coming, and this is screen and this is slit. So the diffraction patterns alternate, dark and bright fringes are forming in this screen. So this capital D is the distance between slit and the screen, and this small d is the width of the slit. So fringe width will be equals to lambda d over d. So we know, so from this beta is directly proportional to lambda, since this d and d will remains the same now for both the cases when we changes the value of lambda. Whatever be the value of lambda, this capital D and small d gonna be the same. So this beta fringe width will be directly proportional to lambda. So beta 1 will be directly proportional to lambda 1. Okay. So taking the ratio beta 1 over beta will be equals to lambda 1 over original length lambda. So lambda 1 new wavelength will be equals to lambda into beta 1 over beta. Since lambda is given as 6000 angstrom into beta 1. Beta 1 is 0.7 into beta, as according to question the angular width of the central maximum decreases by 30%, means 0.7 times of beta over original beta. This beta cancels. So we get lambda 1 is equals to 4200 angstrom. Okay. So new wavelength for which the angular width decreases by 30%. This wavelength is 4200 angstrom, means option B is the correct answer. Now next question 103. A hollow spherical shell of radius r has a uniform charge density sigma. It is kept in a cube of H3r such that the centers of the cube and the shell coincide. So we have to find the electric flux coming out of one phase of the cube. Okay. So this question is from the chapter of electrostatics. See, we are given with a hollow spherical shell. Hollow spherical shell means inside this shell, the electric field is zero. All the charges resides only on the surface of the spherical shell. Okay. And according to question, this spherical shell is kept inside a cube. Let us say this is a spherical shell. Okay, first of all, let us draw a cube. Okay. Let us say this is a cube of its edge is of 3r, and this spherical shell is placed inside this cube such that the center of the cube and the center of the spherical shell coincides. Okay. So we have to find the electric flux coming out of one face of the cube. Let us say from this phase we have to find the flux coming out of it. Okay. So for this, let us say the radius of the spherical shell be r. Okay. Radius of shell be r, and we know that the uniform charge density is given as sigma. Density is given as sigma, na? And the size of the cube is given as 3r. 3r. Okay. So let's say this spherical shell has a charge Q that is residing on the surface of the spherical shell. So let us say small q is the charge of the spherical shell. Okay. Now we know that the charge density, surface charge density is what? Charge over area. This is the formula for any surface charge density. Charge is q over area. Area is 4 pi r square. Okay. So from here q will be equals to sigma into 4 pi r square. Let us say this is equation number 1. Okay. And the cube has how many faces? Cube has 6 faces. So the flux coming out of only one phase will be 1 by 6 of the total flux. So total flux will be, we know that from the Gauss law of electrostatics, the electric flux is equals to 1 over epsilon naught times the total charge enclosed by the surface. And since cube has 6 faces, so the flux coming from one of the face will be equals to 1 over 6 times of the total flux. Oh, okay. So it will be equals to 1 over 6 times of q over epsilon naught. Okay. So from this we get this q is equals to 1 over 6 times of q, and this q is sigma into 4 pi r square. So it will be equals to, so sorry, this is plus na phi. Phi is equals to 1 over 6 times of q over epsilon naught, and from equation 1 this q is sigma into 4 pi r square. So it will be sigma into 4 pi r square over epsilon naught. So flux from one of the phases of the cube will be equals to 2 3s are 6, 2 2s are 4. So it will be equals to 2 by 3 pi r square into sigma over epsilon naught. This is our final answer. So among these 4 options, option D, that is 2 by 3 pi r square sigma over epsilon naught, is the correct answer. Now next question 104. This circuit shows two capacitors A and B of capacitances C and 2C. This is of C, this is of 2C respectively. When they are fully charged, this cell is removed and capacitors are connected with their plates of opposite polarities touching each other. Okay. Then, okay, we have to find the correct answer among these. Okay. So this question is from the chapter of electrostatic potential and capacitances. Potential and capacitance. Okay. Now, we are given with, let us say this is capacitor A, this is capacitor B, and this is E. Okay. This is having capacitance C and this is having capacitance 2C. Okay. Since this A and B are in series, so for series combination, 1 over C equivalent will be equals to 1 over C plus 1 over 2C. It will be, so C equivalent will be equals to 2 by 3C. Let us say this is equation number 1. Okay. And now the charge on each shell before removing the battery will be Q is equals to C equivalent into this E. So it will be equals to 2 by 3 C into E. Let us say this is equation 2nd. And energy before removing the battery will be, energy is for capacitors, the energy formula is half CV square, means half C equivalent V square. So it will be equals to half and CV square, na? So it will be equals to into 2 by 3 into C into V square, and V is what? C into E square. Okay. So it will become 2 cancels, 1 by 3 C E square. Okay. Let us say this is equation number 3. So when the battery is disconnected and the plates are joined in opposite polarity as given in the question, so this C will be equals to Q minus Q as they are connected in opposite polarity over C plus 2C, capacitance of first capacitor A and that of second capacitor B. So it will be equals to 0. So all the energy will be lost and it will be equals to 1 by 3 CE square as before. Okay. since after removing the battery and connecting these capacitors having opposite polarity, the capacitance becomes 0. So for this, the energy will remain the previous one, means half Ce square as the before one. So in this, all these statements, that statement second and third are correct, means the charge on the B is 0, and the third one is loss of energy in the process is 1 by 3 Ce square. So these two are statements are correct. So for this, the option B, that is B and C are correct, is the correct answer. Okay. Now next question 105. A uniform conducting wire AB of length 5 meter and resistance 5 ohm is connected as shown in the circuit. If the balancing point is obtained at 3 meter from A, then the value of E is, okay, we have to find the value of E when the balancing point is obtained at 3 meter from A. Okay. So according to question, this is 3 meter. Okay. Length is given as 5 meter. Resistance is given as 5 ohm. Balancing point is given as 3 meter. And EMF is given as 10 volt. Okay. EMF will be 10 volt according to question. Okay. So let us say this is EMF E1. Okay. Now, the current in the circuit with E1 equals to 10 volt is circuit with given by, since from Ohm's law V equals to IR. So current will be V over R, means V is E1 over R. R means this R1. This R plus R means 4 plus 1. Na? So, okay, small r. Yes, this will be R plus R. And here the small r will be this 4 plus 1. 4 plus 1, it means 5 ohm. And we are given capital R is 5 ohm. So I will be equals to E1 means 10 over this 5 plus small r is 5. So it will be 10 over 10 means current is 1 ampere. Okay. So VAB, potential between point A and B, will be equals to current into resistance, and current is 1 into resistance is 5. So it will be equals to 5 volt. Okay. So from this, the potential gradient is given by K is equals to potential gradient. Potential gradient K is equals to this VAB over I. It is for whole the wire. Current is for the whole the wire. So K is equals to VAB is 5, and current is for whole wire, the current is will be 5 ampere na, for the whole wire. So 5 over 5, it will be equals to 1. So at balancing point, the E will be equals to potential gradient into this length, means this length, this that is given in the question, means L. So K is 1 into 3. So it will be 3 volt. So the correct answer is option B, 3 volt. That is, the if the balancing point is obtained at 3 meter, then the value of E will be 3 volt. Okay. Now, next question is 106. In the given circuit, the equivalent resistance between A and B is, okay. So this question is from the chapter of current electricity. Current electricity, okay. We have to find the equivalent resistance between point A and point B. So we can resolve this circuit as, let us say this is point A and this is 5 ohm. Since these two are in parallel, so for these parallel combination we write here 5 ohm. Since for parallel combination we write 1 over R is equals to 1 over R1 plus 1 over R2. So solving it, we get 1 over 10 plus 1 over 10 means 2 over 10 means 1 over 5. So R will be 5. Okay, so for these two we write 5 ohm. Okay. Now this is 3 ohm. This one is 3 ohm. Okay. And then this is 5 ohm. This one. Then this is 8 ohm. This one. 8 ohm. And then here is 3 ohm. 3 ohm for these two, 6 ohm and 6 ohm. These two are connected in parallel. So again, using the parallel formula means 1 over R is equals to 1 over 6 plus 1 over 6 means 2 over 6. It will be equals to 1 over 3. So R will be equals to 3 ohm. Okay. So for these two parallel combination, we write here 3 ohm. Okay. So now this, for this circuit, new resistance will be equals to uh, this. Okay, the new resistance for this circuit, again resolving it another form, like if we resolve it like this, let us say this is 5 ohm. Okay, this is 8 ohm, this one, and this 5 ohm is like this 5 ohm, this 5 ohm, and this 8 ohm. Okay, and this is 3 ohm, this is 3 ohm, and this will be point B, and this will be point A. Point A, point B, this is point A, point B. This 8 ohm is here, these 5 ohm are like this, and this 3 ohm are like this. Okay, now the ratio of the resistance on both the sides of the junction is 1:1. Okay, 1:1. This condition is equal to the Wheatstone bridge condition. No current will be passed through this 8 ohm. So the net circuit will be equivalent. So for this new circuit, the equivalent resistance will be R equivalent will be equals to 5 plus 3. It means 8 ohm on each side. Okay, 5 plus 3, 5 plus 3, 8 ohm on each side. So they are in parallel combination, and for parallel combination, we know that R equivalent is equals to 8 into 8 over 8 plus 8 means 8 8 is 64 over 8 8 16 means 4 ohm. So the correct answer is 4 ohm, means option B is the correct answer. Now 107. A square loop of side A and carrying a current I is suspended from an insulating hanger of spring balance as shown in the figure. The transverse magnetic field B directed into the paper occurs only at the bottom side of the loop. When the direction of the current in the loop is reversed, then the change in reading of the spring balance is. Okay, so this question is from the chapter of magnetism and matter. Magnetism and matter. Okay. So according to question, we are given a square loop with side of A. Side is given as A, current in the loop is given as I, and magnetic field is B. Okay. So net force is given by the Lorentz equation. We use Lorentz equation to find the net force. Okay. So initially when the direction of the current is clockwise. Okay. Initially when the current direction is clockwise. So for this force net, F net will be equals to Fg downward direction due to gravitational plus what? Lorentz force means BIL sine theta. Okay. So F is mass into gravity in the downward direction plus this I, uh, this L. So here this L will be equals to A sine 90 degree. So it will be equals to 1. So here we write I A into B. Okay, let us say this is equation number 1. Now, when the direction of the current is reversed, according to question, when the direction is reversed, so for this F net will be equals to Fg plus again BIL sine 90 degree. So it will be equals to mg. Now, since the direction is reversed, so it will be minus of IAB. Okay. This is equation number 2. How it is minus? Since for this L will become A sine 180 degrees, since the direction is reversed and sine 180 is minus of 1. So it will be equals to minus of A. Okay. So for this F net will be equals to F1 minus F2. So it will be equals to this mg plus IAB minus mg minus minus plus IAB. Okay. So this minus mg cancels. So F net will be 2IAB. This is our final answer. So the correct option is option B, that is 2IAB, F net. Now next question 108. A current carrying loop is placed in a uniform magnetic field B in different orientation, first, second, third, and fourth, as shown in the figure. The correct order of decreasing potential energy is, okay. So current is circulating in loop equals to I. The current is given as I, na? And magnetic field is given as B. I and B. The potential energy of current carrying loop when it is placed in a magnetic field, it is given by minus mu B cos theta, where this mu is what? Magnetic moment. Okay. This U potential energy is given as minus U mu B cos theta, where mu is the magnetic moment. And for this, mu can be plus minus A. Okay. So if mu is plus of A, then U will be equals to minus of IAB cos theta. Okay. And if it is, okay, let us say this is equation number 1. So for loop 1, okay, for first loop, theta is 180 degree. Okay. So U1 will be equals to minus of IAB cos 180, and cos 180 is minus 1. So it will be equals to plus of IAB. Let us say this is equation number 2. Okay. Now, for loop 2, for second, cos theta is what? 90 degree. Okay. Cos theta is, sorry, theta is 90 degree, na? Theta is 90 degree. So for U2 is equals to minus of IAB cos 90, and cos 90 is 0. So U2 will be equals to 0. Let us say this is equation number 3. For third equation, theta is less than 90 degree, na? So for less than 90 degree, U3 will be minus IAB, and cos is less than 90. For less than 90, U3 will be remains as minus UB cos theta for less than 90. Okay, let us say this is equation number 4. Okay. And for fourth one, the theta seems to be it is greater than 90 but less than 180 degree, means theta is greater than 90 but it is less than 180 degree. So for fourth condition, we write U4 as plus of IAB cos theta. Okay. So from second, third, and fourth, from second, third, and fourth and fifth, we find that U1 is plus of IAB, U2 is 0 minus IAB plus of IAB. So we find that U1 is greater than U4, and it is greater than U2, and it is greater than U3. So the correct sequence is U1 greater than U4 greater than U2 greater than U3, means option C, that is 1, 4, second, and third is the correct answer. Now next question 109. A bar magnet of magnetic moment 2 ampere meter square lies aligned with the direction of a uniform magnetic field of 0.3 Tesla. The amount of work required by an external torque to turn the magnet so as to align its magnetic moment normal to the field direction is, okay. So in this question, we are given with the magnetic moment as 2 ampere meter square, okay. And magnetic field is given as 0.3 Tesla. So work done by the external torque to rotate the bar magnet by 90 degree will be, it will be W is equals to minus of MB cos theta 2 minus cos theta 1. Why we are saying that the torque to rotate the bar magnet by 90 degree means it is because in question it is given that the magnetic moment normal to the field direction. Normal means 90 degree. Okay. So work done will be equals to minus of MB cos theta 2 minus cos theta 1, means theta 2 is 90 as the normal is given in the question, and theta 1, let us say 0 degree. So work done will be equals to minus of MB cos of 90 degree minus cos of 0 degree. And cos 90 is what? 0, and cos 0 is 1. So it will be minus of MB minus of M. So it will be equals to plus of MB. Okay. So, yeah. So M is what? Minus of cos 90 is 0, na? And cos 0 is 1. So it will be minus 1 to minus minus plus. So M is given as 2 and B is 0.3. So it will be equals to 0.6 joule. So work done is equals to 0.6 joule, means option C is the correct answer. Now next question 110. A conducting rod is moving towards right to a velocity v in a uniform magnetic field B. If the direction of induced current I is shown in the figure, then the direction of B is, okay. So we have to choose the correct answer from all these four options. Since velocity is moving, V, it is moving in this direction, current is in this direction, we have to find the direction of B, okay. So for induced current direction, we will use Fleming's right hand rule. Fleming's right hand rule, okay. So this rule states that if thumb, forefinger and middle finger of right hand are mutually perpendicular to each other, then if forefinger indicate the direction of magnetic field and the thumb shows the direction of the motion of the conductor, then the middle finger will show the direction of induced current. Means, let us say, if this is motion, this is field, and this is induced current. Means if forefinger indicates the direction of magnetic field B and the thumb shows the direction of the motion of the conductor, then the middle finger will shows the direction of the induced current, okay, and hence the direction of the EMF. So from this diagram we can say that and applying the Fleming's right hand rule, the direction of magnetic field is perpendicular to the plane of the paper and into the plane of the paper, okay. Magnetic field will be perpendicular to the plane of the paper and into the plane of the paper. So the correct answer is option C, perpendicular to plane of the paper and into the plane of the paper. Now, so the 111th one, a coil has a resistance of 30 ohm and inductive reactance of 20 ohm at 50 hertz frequency. If an AC source is a 200 volt, 100 hertz is connected across the coil, the current in the coil is, okay. So this question is again from the chapter of the alternating currents. Alternating currents, okay. So in this question, we are given with a coil and this coil has a resistance of 30 ohm, sorry, and inductive reactance, means we are given with the value of XL. XL is given as 20 ohm and frequency is of 50 hertz, okay. So we have to find the current in the coil. So given R equals to 30 ohm, XL is equals to 20 ohm, and frequency is given as 50 hertz, okay. 50 hertz. So potential is given as 200 volt, na? Yeah. Let us say new potential, source new potential, okay. Source new potential is given as V equals to 200 volt and new frequency is 100 hertz. New frequency is given as 100 hertz, okay. So we have to find the we have to find the current in the coil, na? So for this, the inductive reactance will be, let us say, inductive reactance XL. It will be, XL is what? Omega into L, and omega is what? 2 pi into frequency into L. So it will be equals to, XL is given as 20. So 20 is equals to omega into L, means 2 pi, frequency is given as 50 into L. So when frequency is, let us say when frequency is 100 hertz according to question, so XL dash will be equals to omega dash L. Okay, so it will be equals to 2 pi into 100 into L. So XL dash will be equals to 2 pi into 50 into 2 into L. So for this, XL dash will be equals to this 2 pi into 50 into L. It is equals to what? Simply XL. So for this term, we can write 2 into XL, na? Because this 2 pi 50 L is nothing but equal to XL. So from here also we can write 2 pi this 50 into L equals to XL into this 2. So we can write XL dash as 2XL. So it will be equals to 2 into, and XL is given as 20. So we get XL dash new impedance will be equals to 40 ohm new inductive reactance. Okay. So impedance of the circuit Z will be equals to what? Under root of XL square plus R square. This is new inductive reactance. Okay. New inductive reactance. So for this impedance will be equals to XL square plus R square. So it will be equals to XL is what? 40 square plus resistance is 30 square. So solving it we get 50 ohm. So now using Ohm's law, okay? We know that from Ohm's law, V equals to what? I into R, and we have to find current na, in this circuit. So current will be equals to voltage over resistance, and voltage is given as what? 200 volt. So 200 over R. R is 50. So solving it, we get 4 ampere. Okay, so this is our final answer. Means the current flowing through this circuit, coil will be what? 4 ampere. Okay. Now, next question, 112. A current I is flowing through a wire of length L. If it is made into a circular loop of 1 turn, then its magnetic moment is. Okay. So, students, this question is from the chapter of moving charges and magnetism. Moving charges and magnetism. Okay. Now, given in the question, current I in the wire, and wire length is given as L. It is wire length. Okay. Now, when the wire of length L is bent into a circular shape or circular loop of radius R, then we can write R is equals to this length over 2 pi, because 2 pi is the circumference of the circular loop. Na? So for this, we can write R radius as this whole length divided by 2 pi. Okay. So area of circular loop will be pi r square, pi into r square. So r is what? L over 2 pi whole square. Okay. So now this magnetic moment will be equals to current into area. The simplest formula for magnetic moment, M is equals to current into area. Current is what? I into area is what? Pi over L into L over 2 pi whole square. Okay. So it will be equals to, solving it, we get L square. 1 pi power cancels. So L square into I over 4 pi. Okay. So this is the final answer. So from these given 4 options, option A, that is L square I over 4 pi, is the correct answer. Okay. Now next question, 113. Energy released in the fission of a single uranium nucleus is 200 mega electron volt. Then the number of fissions per second to produce 5 milliwatt power is. Okay. So student, this question is from the chapter of nuclei only. Okay, in this question, we are given with the energy equals to what? 200 mega electron volt, and power is given as 5 milliwatt. Okay, so using formula, energy over time is equals to what? Power. So from here, we can write power is equals to energy. If we are given n number of fissions, so n into E over T, where n is what? N is the number of fissions reaction. So n by T is equals to what? P over E. So it will be equals to power is given as 5 milliwatt, means 5 into 10 to the power minus 3 over E. Energy is given as 200 into 10 to the power 6, and it is given in terms of electron volt. So convert it into joule by multiplying it with 1.6 into 10 to the power minus 19. So for this we get N over T is equals to 1.56 into 10 to the power 8 fissions per second. Okay, fissions per second. So our correct answer is option A, that is 1.56 into 10 to the power 8. Okay. Now next question 114. Match the electromagnetic radiations given in list 1 with their uses given in list 2. Okay. So this question is from the chapter of electromagnetic waves. We have to match list 1 with list 2. Okay. So in list 1, the first one is X-rays, okay? So X-rays are used to study the crystal structure by Bragg's law method, okay? So this A matches with R in list 2, okay? Now next B1 is UV rays. So UV rays are used to study the fingerprint in forensic labs, okay? So this B matches with Q. C1 is radio waves. So radio waves are used in TV communication for sending the signals to large distances. Okay. So C matches with S. And D1 is IR ray. IR rays. Okay. Infrared rays. So these infrared rays are used in TV remotes to send signal for short distances. So this P matches with P. Okay. So from these, the correct answer is option B. So here we end. Now next one is 115. The ratio of longest wavelengths of the spectral lines in the Lyman and Balmer series of hydrogen spectrum is, okay. So this one is from the chapter of Balmer series now. So it is from the chapter of atoms. So the question is asked to find the longest wavelength, okay? So we know that the spectrum is like the first one is Lyman series, second one is Balmer, third one is Paschen, Lyman, Balmer, Paschen, bracket, and then at last P fund, okay? This is P fund. So for Lyman, n equals to 1, then n equals to 2, 3, 4, 5. Okay. So we have to find the longest wavelength of the Lyman and Balmer series of hydrogen spectrum. So the Lyman series largest wavelength occurs when transition takes place from N1, from let us say initial one is from 2 to final one is 1, okay? Means when the transition is from 2 to 1, so we get the largest wavelength for the Lyman series. And when the transition is from n equals to 3 to n equals to 2, we get the largest wavelength for the Balmer series, okay? So we know that the wavelength formula for such type of question is 1 over lambda equals to R, where R is the Rydberg's constant, 1 over NF square minus 1 over Ni square, okay? Now, this is equals to frequency mu, okay? So for this, write 1 over lambda maximum, because we are asked to find the maximum wavelength. It is equals to R. This one is, let us say, for the Lyman series, okay? So 1 over 1 square minus 1 over 2 square. So it will be equals to R 1 over 1 minus 1 over 4. So solving it, we'd get 4 minus 1, 3R by 4, okay? This is for Lyman series. Let us say this is equation number 1. Now for Balmer series, we can write Balmer series, mu is equals to again 1 over lambda maximum. It will be equals to R 1 over NF square minus 1 over Ni square, means 1 over 2 square minus 1 over 3 square. So it will be equals to R 1 over 4 minus 1 over 9. Okay. Now solving it, we get R 5 over 9 4 36. So this will be 1 over lambda maximum for Balmer series. Let us say this is equation number second. So we have to find the ratio of the longest wavelength. Okay. So for ratio, we write lambda maximum for Lyman. It will be equals to this one is 3r by 4 na, means 4 by 3r over lambda maximum for Balmer. So it will be equals to what 36 over 5 into r. So this r cancels each other. So we get 4 5 4 is a 36. So we get lambda maximum of Lyman over lambda maximum of Balmer is equals to 5 over 27. Okay. So the ratio is 5 ratio 27 or 5 over 27, means option B is the correct answer. Now next question 116. The graph given in the figure shows the variation of photocurrent I and the applied voltage V for the different materials and for two different intensities of the incident radiations. Then the curves which represent the same material are okay. This question is from the phenomena of effect photoelectric effect. Okay, what happens in a photoelectric effect when the light of a sufficient frequency having wavelength lambda, let us say a photon which is having a lambda falls on the surface of the metal, then the electrons are ejected from the surface of the metal, and these ejected electrons are called photoelectrons. Okay, and the current generated because of these photoelectrons is called the photocurrent. So we are asked to find the curves which represent the same material. Okay, so in this figure, the materials will have same stopping potential and different materials will have different stopping potential, which whatever may be the intensity of the incident radiation. So the curve first and second and third and fourth represent same material. Okay, so first, second and third, fourth, they will represent the same material. So option D, that is third and fourth, will be the correct answer. Okay. Now next question 117. Half-life of a radioactive substance A is 2 times the half-life of another radioactive substance B. Initially, the number of nuclei of A and B are Na and Nb respectively. After 3 half-lives of A, the number of nuclei of both are equal. Okay. So we have to find the ratio of Na over Nb. So this question is from the chapter of nuclei. So in this question, we are given A half-life. A half-life is 2 times the B half-life. Means let us say we write A's half-life is equals to 2 times B's half-life. Okay. Half-life. Okay. So initial number of substance of, let us say, A will be Na according to question, and initial number of substance for B is Nb as given in the question. So the number of substance remaining after n half-life. From the formula, we know that n is equals to n naught 1 over 2 power n. This is the standard formula for the calculating the half-lives. Okay. Means the number of substance remaining after half-life. This is the formula for it. So according to question, okay, we are given A with Na and B with Nb na. So for this, n equals to 3 F as given in the question for substance A, and n equals to 6 for substance B, as according to question, A's half-life equals to twice the B's half-life. So n equals to 3 will be for A, for as in the given in the question, and for B it will be 6. Okay. So the remaining portion for A will be remaining portion of A will be equals to Na 1 over 2 power 3, and for B it is Nb 1 over 2 power 6. Okay. So solving it, we get, since in the question it is given that the number of nuclei of both the both the substances are equal, so equating these two means equation 1 and 2. Equating 1 and 2, we get Na 1 by 2 power 3 will be equals to Nb 1 by 2 power 6. Okay, so Na over Nb will be equals to 1 by 2 power 6 over 1 by 2 power 3. So solving it, we get 1 over 8. Means the correct answer is option D. Now next question 118. When an n-type semiconductor is heated, so we have to find the correct answer. Okay, so this is from the chapter of semiconductor itself. So when an n-type semiconductor is heated, due to extra thermal energy, some of the covalent bonds break. This produces electron hole pairs in equal number. Okay, so from these four option D, that is number of holes and the electron increases equally, will be the correct answer. Now next question 119. We are given with the 5 logic gates. If A and B are the inputs, Y is the output, then we have to find the correct truth table for this. Okay, logic gates. So this question is from the chapter of electronic devices. Electronic devices. Okay, let us always add. Let us say this is point A na, this is point B. Let us say this is D1. These two are what? These two are NOT gates. Let us say this is D1, this is D2. Since these are AND gate and this D3 is also AND gate, okay? Let us say we write it as X input, which is also coming from A in this NOT gate. And from B, we write it as Y, which is as an input in this NOT gate, okay? So for these, D1 and D2 and D3 are NOT gates, and these two, D1, D2 and D3 are AND gates, and these two are NOT gates, okay? So for D1, we will write it as, okay, Y bar into X for D1, okay? And for D2, we will write X bar into Y. And for D3, we will write D1 dot D2, okay? So D3 output will be equals to XY bar into X bar Y, as D3 is also a AND gate. So it will be equals to XY bar into X bar Y, it will be equals to 0. So solving it by writing the truth table, we find truth table, okay? So let us say this is A, this is B, and this is Y. So when A is 0, B is 0, so Y will be 0, okay? When A is 1, B is 0. So from these conditions, we write Y is 0. For A is 0, B is 1, Y is 0. For A 1, B 1, Y is again 0, okay? So from these four options, 0, 0, 0, 1 na. So option A is the correct answer, okay? Now next question 120. Consider the following statement regarding digital signals. Okay, this is again from the chapter of electronic devices. And it is asking about the digital signals, okay? Devices. So this can be from the communication also, okay? So from this, we have to find the correct answers. So digital signals uses, first of all, they uses binary system, means 0 and 1, okay? This leads to discrete wave produced from digital signal. They are in the form of the rectangular wave. These are in the form of rectangular waves, and they can utilize the binary system, okay? And digital signal cannot provide a continuous set of value because it is not using hexadecimal system, which gives continuous values, okay? So from these, we see that discrete step is also the correct one. So second, third, and fourth are the correct answers, okay? So it means option C is the correct answer.